So the first sample that we'll have a look at, and it's potentially quite a tricky sample that I've seen quite a few times in training, is this metallic doorknob. So obviously it's been taken off the door, and this has been grabbed, so we have bloody fingerprints on the doorknob itself. So I've started off with my go-to lighting technique for these sorts of shaped items, which in this case is the goosenecks. And after experimenting with the position of the lights and the polarizers, this is the best image that I can get from this particular sample. And you can see we're struggling with the reflections because of the curved and reflective nature of the sample. But what we'll show you now is using another technique, using the paddle lights, and we're sort of taking this specular illumination and taking it one step further for looking at curved surfaces. So we'll have a look at that now. So using this paddle light, I've just repositioned the doorknob slightly, and what I'm attempting to do is to use a long shutter speed. So in this case will be maybe 3 or 4 seconds, and during that 3 or 4 second exposure I will be moving the light so that the reflection is being cast over the entire fingerprint. So as I look down the camera now and I'm positioning the light, I can see certain parts of the fingerprint are being illuminated, but I can't see the whole fingerprint in one go. So that's why we'll take a long exposure and capture the movement of light over that exposure itself. So using the shortcut keyboard, I can just click spacebar and then just position the light, and now the photo's finished taking, and that will be our result. In this next slightly simpler example, quite a common problem that people encounter is when photographing mirrors or highly reflective surfaces. So mirrors and CDs sometimes can often present a problem, even if the fingerprint is very well developed. If you're using goosenecks or other conventional lighting techniques, you quite often see this kind of halo double fingerprint effect, where the fingerprint is actually being reflected off the layers within the mirror or the CD. So the one way we can get around that is using the coaxial light box. So because of the way the light is illuminated perpendicular directly down onto the surface, we're not getting those double reflections, and as you can see we get a very nice clear, crisp ridge detail from the surface. In this example we have a tool that has been used as a weapon, and we have fingerprints in blood, both on the blade and on the handle. But for the moment I'm just going to concentrate on the fingerprint on the handle, or the wooden handle. And the light source that I've chosen for this one is actually the dark field ring light, which is more traditionally chosen for photographing 3D fingerprints or fingerprints impressions in things like blue tack, putty, dried paint and so on. But in this case you can see it does actually work very well in terms of also, well, first illuminating the fingerprint very well, but also reducing the effects of the striations in the wood as well. Which is a common problem that would interfere with some of the ridge detail. So using the dark field ring light, and again you can just be a little bit selective about the exact positioning of the light itself, and again using the keyboard shortcuts to take a preview, and then we can see our final image and some of the fine ridge detail that we're able to see on this print. One quite common item that a lot of labs will photograph is bottles or plastic containers, things like this. And again, the go-to light source that we recommend for this would be the goosenecks. So you've seen examples where we've been lighting externally, and you commonly have the goosenecks at quite a low angle either side of the fingerprint. But another example that's often overlooked is actually placing one of the light sources inside the bottle, illuminating the whole thing from the inside, almost acting like as a giant transmitted light. So in order to do that, just remember to remove the polarizing caps on the end of the gooseneck so it's able to fit inside the bottle. And you can experiment with the positioning itself a little bit as well, but generally you'll find that you just get a very nice transmitted light. You do not have to worry about uneven reflections and positioning, fine positioning of the goosenecks. An example here, we have a very evenly lit fingerprint, which we can then process further. And finally, the last example, we'll just revert to something a little bit more simple, and it's often a principle that we start out when we do DCS training, and that's the importance of using the polarizing filters. So I've gone back to, just in this case, a clear glass bottle that has been superglued, so processed with cyanoacrylate. And we're going to use the goosenecks, which is probably the most common light source for this type of sample. And with the goosenecks, remember, you have polarizing filters on the ends of each light source. And with this, you should also have your polarizing filter on the lens as well. So all three will work in combination. So one of the things I see quite a lot is either people not using the polarizing filter or just forgetting to use them or optimizing them for each fingerprint. So we've got a preview here in this particular example where the polarizers are set up in the worst position. But either using the live mode in the camera, or my preference is actually looking down the camera itself as well, adjusting the polarizers, we can achieve an image that has much better contrast and much stronger ridge detail as well. So you can see, for example, the difference in the finer details here, where we're almost losing some of the ridge detail in the background. It's quite patchy, but when setting up the polarizers correctly, we can see the ridge flow much clearer over the entire fingerprint. So this, in combination with positioning the light sources, is one of the key things when illuminating fingerprints on this type of sample.